So the whole idea of a Gauss transform, let's see if I can do this off the top of my head. I didn't. So the real question is, does your teacher remember? Transform. How to spell Gauss transform. All right. So we call the Gauss transform something like this. In minus tau k ek transpose, where, oh God, with tau k was zeros, and then the k plus first element of tau k was allowed to be non-zero. And I think we call this thing tau k minus 1, or tau k plus 1, all the way down to tau n. Right? And so the whole idea of this one, let's take a look at L1 here. So L1 looks something like this, right? All right. Could you break this into two different matrices? Could you break this into identity matrix and then a matrix with non-diagonal elements? What would that look like, Adam? Awesome. Yeah, let's be really explicit. Let's factor out the negative to make the definition and the example look identical, right? Okay, so what would that look like? I mean, let's do it in 2 steps, actually. It's always better to do this thing in steps. Yeah. Okay, so that's not a negative yet. What would you do to factor out that negative? Yep, and then I have 1, 1, 0, 0, 0, 0, 0, 0. Anybody see an outer product there? So this thing is now L1 is I3 minus, what's this outer product? What column is it in? It's in the first column. And then what vector is in that column? Yep. Okay, so let's go ahead and do that. I3 minus. Remember, tau sub k has all the first k elements 0, and then the k plus first element is non-zero. So what tau would this be? Tau 1, E1 transpose, right? With tau 1 equal to 0, 1, 1, something like this, right? And in fact, if we were to look at the original matrix, this was 0, negative A21 divided by A11, negative A31 divided by A11. You could actually just, well, sorry. These weren't negatives, right? Because we factor out the negative, right?